Section 1.2 Subsets, Video 4. In this video, we will cover the following objective: use Venn diagrams to display set relationships. Let's start with the definition. A Venn diagram can be used to visually represent the relationships among sets. So a Venn diagram normally includes a rectangle or some sort of shape. And then a set can be represented using a circle or an oval usually. So we'll use a circle. And sometimes the name of the set can be written off to the side or sometimes maybe even inside. And then the elements of the set are listed within that or are represented within that circle or oval or whatever shape we're using. So for example, let's say that A is the set of natural numbers from 1 to 5. We would just place those elements in set A like that. Now, Venn diagrams can be used to represent sets and relationships among them. So this Venn diagram is representing set A, where A is the set of natural numbers between 1 and 5. Now, multiple sets can be represented in one Venn diagram. And here are some common relationships that we might notice among sets. So we'll start with disjoint sets. Definition: two sets that do not share a common element are called disjoint sets. For example, the set A equals 1, 3, 5, 7, 9 and B equals 2, 4, 6, 8, 10 are disjoint because they do not have a common element. Example 5, determine whether the given sets are disjoint. Part A, set A is the set of X such that X is equal to 2 times N, where N is an element of the natural numbers, and B is the set of X such that X is equal to 2 times N minus 1, where N is an element of the natural numbers. All right, if N is an element of the natural numbers, that means that N could be 1, 2, 3, 4, etc. And so we'll use that to build the sets. So let's say that N equaled 1. Then we would have 2 times 1, which is 2. All right, the next natural number would be 2. So if N equaled 2, then we would have 2 times 2, which is 4. The next natural number would be 3. So if N were 3, then we would have 2 times 3, which is 6, and so on and so forth. This is an infinite set representing the even values. We could do the same thing to build set B. So if N were 1, then we would have 2 times 1 minus 1, which would give 1. The next natural number that we could fill in would be 2. So that means that we'd have the element 2 times 2 minus 1, which is 3. The next natural number to fill in would be 3, which would give 2 times 3 minus 1, which is 5, and so on. This is an infinite set representing the odd values. These are disjoint. One set represents even natural numbers and the other set represents odd natural numbers. These do not have an element in common. Part B, set A is the set of all X such that X is a professional athlete, and set B is the set of all X such that X is a U.S. veteran. These sets are not disjoint because there are many professional athletes who were also U.S. veterans. So those sets would have people in common. Set relationships. As I mentioned, Venn diagrams may be used to demonstrate the relationship among sets. For example, Venn diagrams can be used to represent equal sets, subsets, sets with common elements, and disjoint sets. So let's talk about equal sets first of all. If A equals B, then these sets are represented using the same circle in the diagram. So basically, if we created a Venn diagram here, we would have one circle that represents set A and that also represents set B. So we can even write A equals B off to the side there. Proper subsets. If A is a proper subset of B, then the circle representing set A is completely enclosed in the circle representing set B. So recall, by definition, A is a proper subset of B if every element in A is also in B and sets A and B are not equal. So in other words, set A is completely enclosed in set B. So we would have set A, and then we would have set B. An example, if we're looking for an example, perhaps set A contains the values 5, 7, and 9. And suppose that B contains the values 2, 5, 7, 9, and 11. So we would have 5, 7, and 9 that would be represented within set A. And notice those are also within set B as well. And then the elements that are in B but not in A would be written off to the side there within the B circle but not within the A circle. Overlapping sets. If sets A and B have at least one common element, then the circles representing these sets will overlap. Common elements are placed in the middle section where the circles overlap. So let's say we have set A, and let's say we have set B. If we're looking for an example, let's say that set A contains the letters A, E, I, O, and U. And let's say that set B contains the letters A, B, C, D, E. Notice that these sets have letters A and E in common. So those would be placed in the middle section where those sets are overlapping. The other elements of set A would be placed off to the side in the A circle, but not in the B circle. Likewise, the remaining elements in set B would be placed in the B circle, but not within the A circle. And we saw earlier examples of disjoint sets. If sets A and B are disjoint, then the circles representing these sets will not intersect. Recall that disjoint sets do not share a common element. And so if sets A and B are disjoint, these would not overlap. We saw examples of disjoint sets earlier, but one example that we looked at is, let's say that we have some odd values and then some even values. So that would be what that Venn diagram would look like, and that's how that is representing disjoint sets. Earlier in this section, we talked about common number sets, natural numbers, whole numbers, integers, rational numbers, irrational numbers, and real numbers. And this diagram here is giving us a visual representation of these common number sets. Recall that natural numbers are the counting numbers. Whole numbers are the counting numbers along with 0. So the natural numbers are a proper subset of the whole numbers. Integers contain natural numbers along with their opposites, along with 0. And so although not all these values are listed, so for example, there are more natural numbers than just 1, 2, and 3. It's an infinite set, but these are just examples of numbers that would appear within that set. And so if the natural numbers contain 1, 2, and 3, whole numbers would contain those along with 0, and integers would contain all of those along with values like -1, -2, and -3, and so on. All of those values would be considered to be rational numbers. So all of those would be proper subsets of the rational numbers, which can be written as the quotient of integers. Irrational numbers are numbers that cannot be written as the quotient of integers, and therefore, rational numbers and irrational numbers are disjoint sets. And then real numbers encompassed all of these different types of numbers. And so we can see a visual representation of these different number sets. Again, the numbers here are just examples of values that would belong to those sets. And this concludes section 1.2.